All right, this is a 3x3 system, 3 equations, 3 unknowns, and we are going to solve it by elimination. And so the idea of elimination is we want to reduce this 3x3 system to a 2x2 system that we can solve using our Algebra 1 methods. And so your first step is to find what I call your scaling equation. So you're going to pick an equation, and I like to number them so I can stay organized. So equation 1, 2, and 3. So look for an equation that has a variable that doesn't have a number in front of it. That's going to be easiest to scale and use it to eliminate that same variable in the other equations. And so if you look at equation 1, this x doesn't have a number. Technically it's a 1, but it's invisible. And so that's going to be the equation I want to use. And I'm going to eliminate the x variable in the other 2 equations. And so once I've picked my scaling equation, which is equation 1, I'm going to identify what I need to multiply it by in order to cancel the x's in the other equations. And so if I want to cancel the x in equation 2, they're already ready to cancel. I have 1x and then I have a negative 1x. When I add those together, they cancel each other out and add to 0. And so I don't have to do anything to equation 1 or 2 to make that cancel. And so I'm going to go ahead and write down equation 2 and equation 1 right here. And so I have negative x plus 5y plus 3z equals 2. And then equation 1, I have x minus 6y minus 2z equals negative 8. And so now when I add these together, the x's cancel, leaving me with just negative 1y plus 1z equals negative 6. And so this will be our equation 4. I'm going to put a box around it. We'll come back to it. Okay, and so that's going to be part of our 2x2 system that we're going to solve. We're going to do the exact same thing. We're going to use equation 1 and equation 3. So we used 1 and 2. Now we're going to use 1 and 3. And so in order for this x to cancel with this x term, I would need a negative 3 in front of this. And so I have to scale this entire equation by a negative 3. And so I'm going to write negative 3 times equation 1. And then I'm going to write equation 3. Okay, and so negative 3 times equation 1 would give us a negative 3x, a positive 18y, a positive 6z, and then a positive 24. Just scaled all of equation 1 by negative 3. Scale just means multiply. Okay, and then we can copy down equation 3 just as it is. 3x minus 2y minus 4z equals 18. Okay, and so now when I add these together, the x's will cancel. You have to make sure when you do this step and this step that you're canceling the same variable each time. We want our final equations to have the same variable. So I canceled x here. I also have to cancel x here. Just because it's easy to cancel a different variable, you don't want to do that. You have to cancel the same variable in both steps. Okay, and so that leaves me with a 16y plus 2z, and then 18 plus 24 is 42. Now, when you get to this step, before you commit to your next equation, if you want to scale that equation by a fraction or dividing, you can divide each of these numbers by 2. Anytime I can do that, I try to do that to keep the numbers smaller. And so this would simplify to 8y plus z equals 21. And so I'm going to call that my equation 5. Okay, you don't have to do that step. I just like to keep the numbers small. Okay, and so now my 2 by 2 system from equations 4 and 5 has negative y plus z equals negative 6, and then 8y plus z equals 21. I have y's and I have z's. If you still have an x, that means you didn't cancel the x in both equations. That's why it's so important that you cancel the same variable in both steps. Okay, so we can continue using elimination. We can cancel the z's if I multiply this equation by a negative 1, or you could cancel the y's if you just multiply the top equation by 8. I'm going to go ahead and multiply this bottom equation. Actually, I'll go ahead and multiply the top equation by a negative 1. It doesn't matter which one, as long as you have a negative z here and a positive z here. Okay, and so that gives me positive y minus z equals positive 6. And so I can add these together, giving me 9y, z's cancel, equals 27. I solve for y by dividing by 9, and that gives me y equals 3. Okay, and so once you have your y variable, you can go back to either this equation or even the scaled version to solve for the z. We're not ready to go back to any of this until we finish this system right here for y and z. And so I'm going to pick this original top equation, negative y plus z equals negative 6. And I put parentheses where y used to be because now I know it's negative 3. And so that simplifies to negative 3 plus z equals negative 6. Add the 3. You have z equals negative 3. So now that we have y and we have z, you can go back to any of these original 3 equations, whichever one looks nicest to you, and solve for the x. It doesn't matter if you pick 1, 2, or 3, it'll give you the same answer for x, as long as you're using the correct values. And so I'm going to pick this top equation, and we're going to sub in 3 for the y and negative 3 for the z. And so x minus 6y minus 2z equals negative 8. I put parentheses where the variables used to be because I know y is 3 and I know z is negative 3. Okay, this simplifies to x minus 18 plus 6 equals negative 8. Combine these like terms. I have x minus 12 equals negative 8. Add your 12 to both sides. X equals positive 4. Once you have your x, your y, and your z, you write your solution as an ordered triple. You have your x, then your y, then your z. And so my x is 4, my y is 3, and then z equals negative 3. And so this would be the point of intersection of these 3 lines in the XYZ plane, 3 dimensions.